Okay. Um, this question is basically about a scallop whose shell has an abductin in it, and we're going to use the Young's modulus. Um, we're going to use a Young's modulus of 2.0 times 10 to the 6 newtons per meter squared. Um, and from this Young's modulus, we're going to note that a piece of the abductin is 3 millimeters thick and has a cross-sectional area of 0.5 centimeters squared. And so from this information, we want to know how much potential energy is stored when compressed 1 millimeter. So this is a question regarding elasticity, and hence we're going to be using the Young's modulus. So the Young's modulus is defined, we just call this Y, and this is equal to the perpendicular force divided by the area, cross-sectional area, and this is all over the change in length divided by the total length of the, and this length is going to be the abductin, what's called the abductin. So notice that we were given some quantities, and these quantities were the Young's modulus, which is 2.0 times 10 to the 6 newtons per meter squared. So let's write that down. 2.0 times 10 to the 6 newtons per meter squared. And so this is all going to be equal to, what we need to do is we need to find the force, because it's from the force that we're going to be able to find the potential energy, and from there we'll be able to solve our problem. So the force would be equal to this. We have the force, perpendicular force, and notice that the cross-sectional area is 0.5 centimeters squared, so we have to convert that. So this will be 0.5 centimeters squared. And this is going to be converted such that we have this like this. 1 centimeter divided by 0.01 meter squared. And we also have our ratio, this change in length over the length that was given here. And we flip that over, we take the reciprocal of that to bring it into the numerator. And we found that we had 0.003 as a length in meters. And this is all over 0.001 in meters. So therefore our force, we multiply this quantity over here times this Young's modulus. This gives us our force, perpendicular force. And this will be, once we work this out, this will be 2.0 times 10 to the 6 newtons per meter squared. This would be divided by 6.0 times 10 to the 4 meter per meter squared. And this gives us a value of the force as 33.33 newtons. Okay, so from this point, we have to look at a value with an equation which is called Hooke's law. Hooke's law is given as the force is equal to kx. And we also need the potential energy, which is what we're looking for. Potential energy is given as 1/2 kx squared. So you can see we have a force, and we'll call this a perpendicular force right here. We have a force which was given here. This force will go into this equation, but we have to substitute this equation for the force into this equation for the potential energy. And so when we do that, we end up with a potential energy of 1/2 times the force times x. And let me get out my calculator. We have 0.5 times 3.33 times 0.001. When we plug these values in, we have 1/2 times 33.33 newtons. And this is times 0.001 meters. This gives us an answer for our potential energy of 0.017 joules. And that's our answer.